Oh, what's going on here? Right, I'm having a Retropower brew. That was a sudden livening up. If I manage to get through this without coughing and spluttering, I'll be absolutely amazed, as I'm not feeling absolutely on form. However, hopefully a Retropower coffee will sort me right out. So, let's go and see what's been going on. Let's start with a couple of really small bits. The badges which came back from machining for this last week, they've come back from anodizing now, and now they've been sent out to Bruce Holder, who's going to do the laser engraving, so possibly have those back next week. NSU, handbrake cables and handbrake assemblies now all in and working. So I think actually we're probably about ready to hand that over. Mustang, we readjusted the tracking. I think I mentioned before, when it went for detailing, we noticed there was a slight wheel clearance issue. When we set the tracking up, we got the caster where we wanted it by adjusting the lower arm, and actually the clearance on the front of the wheel against the wing just touched when you steered. So as a temporary measure to get it to detailing appointment, we just pulled the caster back out of it. But we've now done a proper tracking up again on that, and actually pulled the upper wishbone back to get us the caster we want, so we've got the wheel more central in the arch. So that's all gone really well. However, as part of that, we noticed that the brand new lower arms and brand new ball joints have got play in the ball joints. So we've ordered another brand new pair of lower arms, which hopefully won't have play in the lower ball joints, although I wouldn't be entirely surprised if they did. Morris, I've been working on that again this week. Maybe if we creep round here, might get a better look at it, because it's always an amazing and exciting transformation when you first get all the glass in a car. And obviously we've had the windscreen in for a while, but literally just finished fitting the rest of the rest of the windows. And it's amazing how sort of covering up those sort of spot welded flanges on all the window apertures just brings it together so well. So yeah, I've finished the door builds. George had done a lot of groundwork on that, so it was basically going in for the final time, sealing everything up, fitting the weather strips. I've been testing the central locking before we button it all up, so testing that the key operates at central locking correctly. A lot of opening and shutting doors to make sure it's repeatable as much as possible. And then I was able to get the glass in, get all the frames assembled, get the wing mirrors on, and then with that done, it kind of made sense to get the rest of the glass in. So got the side windows and rear window in, which went really well. And now I've said that, I'm expecting they'll probably all shatter in front of me. But those three rear windows are probably the easiest to fit windows I've done in a long while. So yeah, we are getting there. I'm kind of building up to getting the door cards in on this. We've just got to stick the boot lid back on, but the hinges, machine billet hinges we've done for those are here, so that's ready to go back on. And then yeah, I think we're about ready to get it out on the road. E-Type, I think it was just rolling last week. So we've been now moving forward with things like the brakes. So we've got the Fosway Performance 4-pot alloy caliper kit on it, vented discs. The front brake lines, which were kind of roughly in place, we've now drilled and fitted little these really sort of discrete plastic clips that the brake lines will clip into, but they sit completely under. They're very small. I'm quite happy with those. Adam's been working on the vacuum plumbing, so just getting in. I think I mentioned before, it's quite neat the way they've routed everything from one side to the other in the engine bay using stainless steel pipes that actually sit inside the scuttle area and then flange through on bolted flanges. So the vacuum feeds go up to that side and then back out this side down to the remotely mounted servo and master cylinder. So basically working on the brake plumbing. Fuel plumbing, we'd pretty much done last week. I think he's done the filler cap now, and at the back end he's also been doing the mounting of the rear lights and the little panel that sits between the rear lights. And then James has been working on the dash fascia. So I think last week we saw him welding up all of the bits that we don't want on the dash fascia anymore. As part of that, we reshaped the glove box door to give us a little bit more room on the left-hand side of that to put an air vent in the dash. And then as part of that, we wanted to also remake the sort of cubby hole, if you like, that actually forms the glove box itself, which originally is kind of like a cardboardy fiberboard material. So we thought we'd do a proper job of that and fabricate that in aluminium. Then we'll probably upholster that inside with leather. And then he's moving on to the more elaborate part of the dash build. So all of the mounting area for the Motec screen and then the audio screen underneath. So to allow us to do that more easily, James has done a full 3D scan of all of that area of the dash, the transmission tunnel, the kind of footwells, anything that relates to that basically. So all of that sheet metal bracketry and can be drawn on CAD. And then basically plasma cut and folded to shape, and any three-dimensional pieces that are in there. So possibly the surround around the stereo might end up being a 3D printed part, which again we can design in CAD based around that scan, and then printed or whatever machine parts if there's machine parts. So yeah, he's just in the early stages of designing all of that layout on that. So excited to see that come together. Briefly past Camaro. I'm going to say it in the crowd-pleasing way today. John's been on doing some more fettling on the mock-up radiator. We're just trying to get all the mounts absolutely finalised because there's not a lot of spare space in the front of this. The way we've done the engine bay cowling is the intake pipe will actually come over the top of the radiator. So we've got an air filter sat in front of the radiator for a cold air intake. Then there's also AC condenser and oil cooler for the steering system, which sit in front of the radiator as well. So there's not a lot of room for manoeuvre. And we've also got the holes for the fill points for power steering and radiator in the engine bay metalwork. So it's quite critical that everything's mounted well so that we don't end up with those being out of line when everything's made. So he's been forging ahead with that. And then the coil pack. So I think I said last week I'd ordered the Holley rocker cover / coil pack cover kit that they do. Now I knew when I ordered it that they specify what coil packs fit with that cover, and strangely to me the coil packs that come with a standard crate LS3 aren't amongst the list of ones that fit. But looking at the pictures, I researched a bit and the bolt spacings are definitely the same. Looking at the pictures, I thought they can't be that far off fitting. So we got them here anyway. We've tried the coil packs, and basically they do bolt on, but where the nose of the coil pack that the plug lead pushes onto comes out of the side of the cover, it's just hard up against one side of the hole. So basically we've just overlised all the holes in the cover where the plug leads come out. They're on the lower side of the covers anyway, so you can't see them when everything's in situ. So we've just elongated those. We'll touch up around the edges of them. And that was a nice, easy, neat solution. I was keen not to have to buy 8 new coil packs because they're not exactly cheap. So I think that's a bit of a result, and it's got the look we want. So yeah, it's nice to see the engine bay looking neat and a plan and a route forward with it. Land Cruiser Bobby has been on with the diff control. Or the diff lock control, I should say. So this has been on the cars for a while. We did the testing with the electric diff lock actuator a while ago. And then we were scratching our heads over to whether to use, just basically design our own relay box that controls the diff lock, or whether to use the Toyota unit. And we managed to find a good wiring diagram that showed how the Toyota unit was wired. So we ordered a new one of the little Toyota diff lock control relay boxes. And then we've done a bench test this morning with that, just to check that the actuation is correct. So basically you press the diff lock button, the diff lock controller actuates, and then as soon as it's actually latched in and locked, you see the light illuminate up to say the diffs are locked. And likewise, if you put it in low range, that also locks the diff. And that all worked as planned, so he's now going to go ahead and make the proper final wiring loom, which is the last thing we needed to do before we could get all of the transmission tunnel cover back in. So it's a nice little cornerstone, if you like, that allows us to get the rest of the interior in. The next thing we're then waiting for, which is going to be here on I think the 1st of March, is the machined intake manifold, which then opens up the fuel rails. Once we've got the fuel rails done, we can then pressurise and test the fuel system, which I want to do before we get the seat bases and the seat bases in because they cover the fuel tanks. So I want to test that system because we've got that fuel system with a Venturi pump that sucks from the secondary tank into the primary tank, which then feeds the high pressure pump. So I just want to make sure all that works as it should before we seal all that up. So yeah, we're just finishing off diff lock wiring, getting the tunnel in, and then we're waiting for the intake manifold before we can do a lot more on that. And that about sums it up for in here. So we're going to hand over to Nat and see what's going on in the metal workshop. And I won't see you next week because tomorrow, Saturday, I'm going to America to go for the Daytona 500. And thinking about it, I've got a strong suspicion that this episode will probably go out actually during the race, I guess, thinking about the time zones. So I won't see you next week, but I'll see you the week after, and catch you then.
Well, hello folks, and welcome to Retropower Uncut from the Fabrication Workshop for another episode. And we're going to start this week with the Churchill Jag, just to do things in a slightly different order. Bear with me a bit, I've got a bit of a bunged up nose, I seem to have got another bit of a cold, so just bear with me if I'm not very clear. But this week on Churchill, there's been a bit of a two-pronged attack. Stu's been helping me and George make a bit of progress on suspension-related things, and then Stu's also been getting on with sheet metal finishing type tasks as well. In tandem with that occurring, we've been doing some work on the front end. I mentioned before that out of the ideal path of events, we've decided to revise the front end. For various reasons, some more complicated than others, we decided to revise the front suspension, mainly due to steering and concerns over that, but also due to the suspension geometry really not being ideal and wanting to try and use some more modern parts, and just a cumulative addition of all the failings of the original Mark II Jaguar front suspension setup, which we've addressed before on a previous project. However, we felt we could probably reapproach that problem and possibly solve it in a slightly different way, hoping it was going to be simpler. It's not, it's probably more complicated already. We're trying to look through the options for front suspension that would work, be effective, suitable for the weight of vehicle, in keeping with the level of refinement required, yada yada yada. We looked at revising the Mark II Jaguar setup. That's quite difficult. You end up replacing so much of it. When you actually draw a few sort of ideal lines in the sand, you end up replacing so much of it, it's not really an option. So I then looked at the XJ, Series XJ Jaguar front end, specifically Series 3 stroke XJS. Miles too wide in standard form, ballpark sort of nearly 4 inches too wide. However, it is possible to narrow it. However, because of Jaguar's suspension design, the way they did the design, basically trying to have a pretty low scrub radius, ideal Ackerman, and a number of other variables, means that with the steering rack positioning used as it was, i.e. on the back of the cross member, with a decent amount of Ackerman, it ends up being a very short steering rack. When you then shorten that cross member, it ends up being even shorter. That, coupled with the canted wishbones that setup uses and various other things, led us to look further afield. And we've actually dragged in an XJ40 or X300 Jaguar front cross member to pull that apart, because we're aware that they use these skewed style front wishbones, where instead of using a symmetrical unhanded wishbone and being able to use the same one both sides of the car, they actually use a heavily skewed front wishbone like this, which means that it just makes the geometry, without going into a huge amount of detail, it makes the geometry a bit easier to deal with in terms of steering rack placement, which I suspect is why they did that. That has helped us in some respects and hindered in others. It's a very wide setup, much wider than this car, and the cross member that mounts all those parts is some way away from fitting in terms of width. However, the geometry of the wishbones and all the other parts is actually a lot better than any other option that we have to hand that kind of fits the bill in other respects. The key we've got is that we need to narrow that lot to make it fit the car, and then we need to find a compatible steering rack. So it comes back to the steering rack situation again. So I'm working at the moment to try and find a suitably narrow steering rack. We were close with the Ford Mondeo rack that we've used before on the E-types. However, it's not narrow enough. That's around 600mm between the ball centres, between the inner track rod ends. We need somewhere in the region of 550mm. We could do with one that's 2 inches shorter than a Mark III Mondeo steering rack. So I'm literally currently investigating that. In tandem with that, George has scanned the front end of the car complete, including the jig, and the complete assembled, roughly at ride height, Jaguar X300 front crossmember. And in CAD, he's now shortened that crossmember and assembled it into the correct ride height and correct wheelbase position, correct wheel axle centerline position in the car in CAD, so we can see what fouls what. We've got a couple of clash points which I need to address, one of which is inner wishbone versus aircon compressor, so we're going to have a look at that. A couple of other things. We've got the option to redesign and shorten the upper wishbones a bit, which would do no great harm in terms of camber compensation in the suspension. So there's various options open to us. The biggest fly in the ointment is the steering rack. So that's the bridge we still need to cross, is getting a steering rack that's short enough. Anybody using a Jaguar front end will have come across the same problem. If you want to keep very minimal to no bump steer, getting a rack that's short enough to work with the standard Jaguar geometry is very difficult, because you shorten the crossmember by nominally 100mm, you really need to shorten the steering rack by 100mm, and it was already a very short steering rack, so a bit of a world of pain there. But that's progressing. Moving on from that, Stu has been busy, as well as stripping down the X300 crossmember, which is no mean feat, because getting the bottom pins out is quite tricky. As anybody who's done that before knows, they do like to seize in their bushes, and it's quite difficult getting them out. But the 3/4 drive sockets came out, and he got it all apart, so we got there. He's been doing starting getting through some of the finishing off metalwork jobs. So a little easy bit here. He's done the spot welding on the sections he made around the rear windows that weren't yet finished. He's finished those off. And he's been working on the rear parcel shelf. There were some infills on the ends of the rear parcel shelf that needed making. He's made those, got them welded in. And then there's a fillet section that goes between the rear window and the parcel shelf. He's made that section up, templated it, put that through, put the flanges on it in the Pels nibbler. We call it a pull max. It's a Pels nibbler. But he's turned the edges in that, folded those over, got that in, and I could hear the spot welder beeping away earlier, so he was getting all that spot welded in. And then he's moved on into the boot area, and he's been plug welding and stitch welding in place the fillet sections that we mentioned before that join the boot floor into the inner wheel arches. So he's been getting those in place. So it's all coming along. As I say, we're approaching this sort of latter stage job lists section now, which is where progress really just starts to slow down, dare I say, in that it's quite methodical, quite time-consuming work, and it's kind of the stages we're at with the Escorts, which we'll move on to in a moment. We're going to swing by here. It's not an awful lot of visual things been going on the Redux project. There's been a lot going on in the background, not an awful lot to see here in front of us in the workshop. Scott's been getting some of the seam brazing finished off that hadn't been done before, been doing some modifications in a couple of areas. So there's an accommodation needed in the front of the inner wing here for a large tank. I won't go into further detail, but there's a large tank got to go in there, and that needed some provisions making for it in the inner wing. So George has been drawing up the tank, liaising with Scott, making the templates, making some little forming tools, making a swage block so that the section of inner wing can be then put into this, clamped in place, and then swaged round this piece of 6mm plate, and then likewise the piece of 6mm is used to swage, put a return on the front edge of that panel as well, so that it all fits in nicely. So various drilling templates and swage templates made on the CNC plasma to enable us to be able to produce a number of those parts rather than just one, because we want to be able to do these parts somewhere between 2 and 28 of those parts. Then we have the tooling there ready to make all the parts. So that's what's been going on there. We'll move on. We'll walk past Project Kuma just for a minute. Actually, no, we won't. I'm talking rubbish. We will pause at Project Kuma just for a minute. We mentioned last week about why the body prep was being done on the bonnet. So if you want to know that, watch last week's episode if you haven't. But on this, Sam has been doing the somewhat laborious work of making the front end fit. And it's lots of to and fro. The wings now fit. I think last week when we looked at this, The wings were being made to fit. They're pretty damn close now. Considering they're not screwed on, they're very, very close now. But he's then been making the front end fit, including the revised slam panel. He's made the revised, redone all of the revised slam panel now, so that all fits, and that's pretty good. He's been reworking the original front panel, A, so it fits the revised slam panel, and B, so that the ends of the pressings, which I think we mentioned previously on Project 1, the ends of this pressing are not correct to match the wings, so he's been reshaping those to match the wings, redoing all the flanges, altering all of those so they all match, generally doing a lot of messing around with the front end to make sure that everything lines up with everything else. And I know he's now looking at this, just got the cutting templates in place to cut the holes for these pieces, which are the revised bonnet release mechanisms, which are currently just 3D prints but will be in billet stainless steel. So he's doing the requisite cutouts for those, so that we can, I'll probably move that, I'm going to put that right out of the way because I probably moved it from where it was supposed to be now. But he's been doing he's just getting set up to do the cutouts for those into that front panel, get all that finalised so that can get welded in place. So that's pretty much where that's all at. Moving on from that, we will now go to the other Escort and sort of rewind a little bit, in that we've talked a lot about the front wheel arches on Project 1, which will be the same on Project Kuma here. And we mentioned various stages, but you've probably not really seen the process through from the start. So we mentioned making these epoxy hammer form tools, of which this is one of the fronts. Obviously there are 2 fronts and 2 rears of these, 4 of these tools in total. These are machined from a solid high density epoxy based tooling board, which is commonly used for making repeat use carbon fibre moulds, amongst other things. But another thing it can be used for is a former for hammering steel over, because it's extremely hard and high density, so it will withstand a lot of abuse from metal being hammered over it. Then steel blanks have been cut, various pieces of MDF, shaped MDF to enable clamping of the steel sheet over the tool using various clamps have been made. And then these chasers, which are made from nylon plate, are made. These are borrowed from Andy Hall, Vintage Machines, who we've shown in previous, for the last 2 weeks footage. He's been here. He's now handed over to Tom. Tom will be back on to making these as soon as he's finished the panel fit up on Project 1, because we need to get Project 1 off the lift and into body prep ASAP. So he's working on that at the moment. As soon as that's done, he'll be onto these, which are the wheel arches for this car, for Project Kuma. But he had started, under Andy's watchful eye, making the first of the halves of the front wings, of which this is one. So you can see at a nice stage like this exactly the process. Flat sheet of steel placed over here with wooden chocks under the edges to stop it flapping around, clamped down in place, and then struck through with various soft hammers, rubber initially, and then nylon hammers to shape the steel over this hard edge, over the actual wheel arch lip, and to get the material pushed down far enough to be able to get clamps on both sides of it. And then the material is then chased down using a nylon chase wedge like that and a hammer, and it's progressively chased down. So there will be a board, one of these MDF boards, there'll be a stack of those under here, supporting it up to about where my hand is there, and then the material will be chased down as far as that board, hammer chased down while clamped, using rubber to help clamp the material. That gives it enough movement to be able to stretch downwards and push under the clamp, but stops it returning and stops it bouncing. And once that material is all chased as far as that block's removed, then the material is chased down as far as the neck block, that one's removed, and so on and so on and so on, until you get to this stage. Once you get down here, obviously you can see we're starting to pick up shrinks here, because obviously we started with more material, and as it closes down, as it goes down that slope and closes in, there's too much material here. It forms these tucks. Once you get to these tucked sections, as the material's trying to shrink, then we have to beat these tucks out. So as you can see just there and here, and probably just about see, Tom's started to close these tucks in on themselves. And he'll do that, he'll keep beating that around and around and around, chasing that tuck in narrower and narrower and narrower, and then crushing it onto itself. It's very much like the stump when we do stump shrinking, where you create a tuck and then chase it onto itself and crush it onto itself. give the material no chance to spread. If it can't spread out, it has to just crush onto itself and thicken. The key being not to ever let the material turn over on itself. That's when problems occur. But basically Tom's now chasing those tucks down, getting them pushed down onto the tool, flattened out. That'll thicken that material up and enable it all to sit down onto the jig. Once that's done, he'll move on, get all 4 of these halves for the front arches done. Once they're all done, they'll then do what they refer to as setting, which is basically making this so it sits exactly onto this. What generally happens is it'll be slightly too flat and slightly not deep enough in shape, so it won't fully sit onto the former. So what then has to be done is taking it off here and just gently stretching all of this formed area, all of the shaped area, generally stretching it, giving it a bit more volume, which lets it sit correctly onto the die. So once these are all made, then that'll be the next step, stretching that up, basically using a slapper and a dolly, possibly a planishing hammer, to raise all of this, to gently increase the volume to this in this shape, increase the shape to let it sit on. So that's the next stage there. That's where we're at on that. Moving over to the car, we can then show the finished product on the car, and I'll briefly explain about how that gets grafted in. We'll go to a front wheel arch just to make Jamie's life hard, but you can see the rears there. Mark's just started DAing off. So this is bare metal now, nothing to hide there, that is all as it is. But we'll move on to the front. Tom was working on here. In fact, I think Andy welded this one in, but we'll talk about this one. The one Tom's done is exactly the same. But no, we won't. We'll go around here and I'll make Jamie's life difficult, because then we're looking at the one that Tom put in, so you can see his actual handiwork. Tom was working on this end of last week and beginning of this week. You can actually just make out the weld line from a few of the little pits. The weld line goes right around here. What happens is, once those arches are made on the former, Tom will offer them up, work out exactly where they need to go position-wise from the CAD data that George has got, and then he's left some tabs on the edge of the panel to enable it to be screwed in place, double check the shape, double check exactly where it is, then scribe it out, cut the tabs off, put alignment scribe lines, pairs of alignment scribe lines around it with a pair of dividers, get it lined up exactly, trim it exactly to shape, so there is a perfect gap, or lack of gap, but it is basically a perfect gap of just a bit less than the material thickness all the way around. And then you'll start tacking somewhere from the middle with it all aligned. You'll get a tack on, planish the tack, get another tack on, planish the tack, and then basically control the gap using the tacks. Once you've got a couple to hold it in place, he'll go around, he'll put another tack on with the TIG welder and keep either planishing or not planishing, or increasing the planish and decreasing the planish of those tacks to stretch them to get the gap after each tack exactly back to where it started, going all that way and all that way, alternating, keeping the gap exactly as it started all the way around. That way, once there's a tack every inch or so all the way around that whole join line, you know that there is no stress on either of the panels. They're both exactly where they started. There's no pull, there's no push on the welds, they're exactly where they started. Once all that's done, it's then welded from one end to the other, or I can't remember exactly the order Tom did it in, but basically from one end to the other, in sections of about 20 millimeters at a time, basically between the tacks. Section is welded and then planished down to get the stress back out of that weld, so there's no shrink on that weld. You stretch the weld back by planishing it, so there's no stress there, there's no stress on either end where there's a shrink on the ends of the weld. Takes all that out. Once that's all exactly flat again, it's a very time consuming process. Then the next inch of weld is added. Again, that's planished out, wait to cool down, make sure there's no stress in it, it's all flat, no stress on anything again, and so on, all the way around. It's about a day's work to get that welded. From there to there takes about 8 hours, basically 7 or 8 hours to weld from one end to the other and planish it all correctly. The benefit of taking your time, making sure all that welding in is done correctly, is that afterwards it's flat. Well, it's not flat, but it's the correct shape for the wing. There's no deviation, there's no stress in it, there's no high spots, there's no low spots, it's just the correct shape. That's where taking your time during the welding stage and making sure that every bit, at every stage, the stresses are removed before the next bit's done, means you don't get in a big tangle later on and everything comes out nicely. Now, Tom spent some time then metal finishing, largely getting high and low spots out of the wheel arches, which are inevitable through all the process, and making sure that all the weld line is all planished, finishing the swage lines to make sure these flow correctly through, finishing the bottom corners, getting the returns welded in, doing all the final bits on there, basically making sure that that's all ready for the body guys to then put some spray surfacer on and then prep for paint, and that's about as good a finish as you're generally able to get when grafting a panel. Well, for a start, a panel in 2 pieces together and then grafting them into another aftermarket panel. It's a pretty good result, and now you can actually see the car with the wheel arches as they were designed on CAD, but now in steel and finished. It's quite a nice stage to be at. Following that, Tom's carrying on with the front end. He's going to get the slant panel finalised, welded in place, front panel spot welded in place, the wings pinned in place but not welded yet because we're going to take them off while we do the zinc metal spraying, and the door alignment's finalised, so all the front end alignment can be finalised with the bonnet on, check all the gaps, get everything good there. Then we're going to strip everything out of the car, drop all the running gear out, that'll all go back on the shelf or onto the other Escort. Then the car's coming off here, going onto a rotisserie, and with it on the rotisserie we'll do all the weld finishing underneath, all the tidying up, the TIG brazing underneath, any other finishing off jobs that need doing, and then hopefully by the next episode, but possibly not, I don't know, we'll be into blasting and zinc metal spraying. I might be pushing my luck a bit there, but that's the aim. So I think on that note, we're going to skip over the body shop. Body shop have been doing a lot of bits and bobs basically. They really need to get their teeth into this car. The Dodge Charger was collected on Tuesday. That made it back. That was an exciting moment. That fitted into its transport with about 20mm spare between the front and back of the trailer it had to go into. So that was a bit traumatic and a close run thing, but it did go. That's gone back to its owner, so he's pleased with that, and he's getting on with reassembling that. And then the body shop are doing various other things, parts for the Camaro, various trim parts for various cars, lots of bits and bobs of catching up, finishing off jobs, basically while they're waiting for this really now. But this is key really. They need this Escort in their area to be working with it now, so that's the big push. And I think that pretty much rounds up where we're at on in the fabrication shop this week, and so we'll see you again next week.